Guys. This is a model that I built in NetLogo to simulate a rally using what we call an agent-based model. So that each dot on this map here represent a person who participated in a rally in Hong Kong in 2019. And we tried to simulate the crowd behavior where they would go from point A to point B, which route that they would take. And we use this as a basis to estimate how many people have participated in such a rally within a given time during this process. So let me restart this model here. I just finished a run. You'll hit the setup button on the left, and it will load the map into the model again. And also let me clear some message here. This is the console down at the bottom so that the computer program will communicate to me some status. And here I try to simulate 265,000 people. So as I hit the go button, there are some monitors here, some fancy graphics that help me to keep track of what the little people are doing. So if I right click here and zoom in, this is a magnifying glass, you can see each of this little guy as a dot trying to navigate through this maze that I've built in the NetLogo. And we can see how this little guy kind of mimic the real crowd behavior in cutting corners, dispersing on a strict segment of a road, and then try to navigate through this network from the starting point towards the destination that I've set in this map here on the left hand side. So let me minimize this and walk you through some of the interface. So here again, you can see the guys are walking on the right hand side of the map, going through the road network, and eventually they will come here, making all the turns and kind of march towards the left hand side of this map. And here are some parameters, some buttons that I can tweak that set the model parameter in controlling the crowd behavior of this model. So I can decide how long it will run. Let me zoom in a little bit to look at the interface better. So here I can set how long this simulation will run in minutes. So this model right now, the maximum time I will allow it to run for 8 hours. And whether I allow the little guys to start out as at the Victoria Park as the starting point, or whether I will allow other entrants and the entrances to go in or not. So I can toggle these buttons and whether I allow people to leave early and also other roads that will be open as part of the rally route. Here in Hong Kong, the July 1st rally usually takes place along this Hennessy Road down at the bottom. But at times when people got stuck and they waited for hours, they got impatient and they will break the crowd management imposed by the police and rush into this tributary road network on the side. Like this one is the Lockhart Road. And at some point in 2019, I think some protesters occupied this portion of the Lockhart Road from 4 to 7 p.m. So here are other parameters where I can set when to let those people in, how many people are allowed per little patch, like each cell in this map. So right now we allow a maximum of 5.4 people per square meter. They can walk at a maximum speed of 1.4 meter per second. All of these are based on the literature or maybe from some empirical findings that we have or data that we collected. We can also set the early departure rate and also how many people will join at different gateways of exiting and entrances that is marked by these yellow polygons here. So by the leave rate 19%, it doesn't necessarily mean 90% of all simulated protesters will exit. It basically is a probability for any person whenever they walk past the yellow polygon that I marked here, they kind of like throwing a dice that will present a random chance for them to leave early or not at different point in time of the rally. And we can gauge and monitor the total departure population and see whether that matches or not. Similarly, we can also set the entrance rate for those who started not only at Victoria Park, but maybe anywhere along Causeway Bay or Wen Chai or other places. So we can set the entry rate anywhere from 200 people per minute, anywhere along this rally route here, or any number that we plugged in from 200 people per minute all the way up to 4,000 people per minute at various points and places throughout the rally. We can also set, and we have observed, actually some crowd occupied the main rally route even before the head crowd of the organizer who started from the Victoria Park to started marching along the rally. So we can also select when, at which point of since the start of the rally that will allow them to enter at Causeway Bay, Wen Chai, or other locations. So here are some other monitors to keep track to make sure and verify whether our model is giving us a reasonable simulation or not by simulating how many people are on scene, how many more people do we still need to fulfill the targeted simulation population. We can also keep track of how long it takes to finish the entire rally. How long does it take for the head crowd to finish it? I also summarize all these metrics into these charts that we can export later on into a table so that we keep track of where the people are, how many of them have left early or arrived late or finished towards the end at the destination, how many have got lost over the course, and also how many people we have, their patience level, their 3 ways to navigate. So this is basically the interface. And right now these guys are along this Causeway Road in near Victoria Park right now. And this is the code environment where all the code happens. And we can decide the rules, defining the behavior of the crowd, and also all the model parameters that goes into the model. And we can change any of this and improve the model better. And I have actually set up a GitHub that make this project code open source, and I welcome anyone who is interested to help me refine the model better, or maybe adopt this to model a rally at another location. And hopefully, the more people who join and interested in this work, we can improve the quality of this model. And so that we can better understand the crowd dynamics and also estimate the rally and how many people have attended, so that we can keep a better record for history. So that's about it. I'm going to keep this model running, and it is actually pretty fun to watch, especially if you couldn't fall asleep. And again, you can inspect the different properties of the area throughout the entire rally. You can also follow a particular protesters and keep track of their properties. So each protester, they keep walking. We keep track of the X and Y, where they are, which area that they land on, which direction that they're going, whether they're allowed to move forward or not, the level of patience, if they got stuck because of the patch capacity might have been filled and they cannot walk any further, then the level of patience will change accordingly, and also their approach in wayfinding. They may walk based on the shortest distance or walk wherever there's room in nearby patches, or they may just get so frustrated and walk randomly. So this is how I designed the protesters. We can also keep track of the properties of each patch. So based on how many people occupy that particular space, the speed that protesters are allowed to walk within that space will change accordingly. Um, so this is the model, and yeah, keep watching. I appreciate your interest in this work, and if you have any questions or comments or suggestions, please feel free to email me. Okay, I'm gonna switch gear and show you a video that I have recorded for a longer simulation, just so that you don't need to spend time waiting for the simulation to take place. Because a model with less number of people, like around 210,000 people, it will take about 2 to 3 hours, or sometimes 4, depending on how powerful your processor is. And the 550,000 model can, like 500,000 people, can take up to 12 hours to run. So I'm just going to show you what the model looks like and kind of speed it up in a time lapse. So as we start, then we see the people rushing to the scene, and they go to the two destination in this rally. And I haven't finished it up in this particular simulation, but if I let it run continuously, it will eventually go to this location here, which is the Hong Kong government headquarters, and also at the Chater Square in Central. So basically, like the crowd split in the 2019 rally into two destinations. So with that, that's what the model looks like. And if you're interested, please download it and run it on your end, and you will see how it goes.